Hello and welcome to the video on preparing for Edexcel GCSE Physics Paper 1. Okay, so main focus will be Combined Physics Paper 1, Foundation and Higher, and I'll try to touch on triple because there are a few extra topics for triple. Okay, so again, it's my last minute revision video. It's an overview of what's possibly coming up using the additional information or the advanced information that has been provided by the examination boards. Okay, so what will be assessed or what will not be assessed? So according to the additional information, Newton's first and second law will not be assessed on the foundation paper. Newton's third law will be assessed on the higher paper. Also, renewable and non-renewable energy is not expected to be assessed on both the foundation, higher, and on the triple paper. Okay, so let's go into key things we need to be focusing on. Okay, so for the foundation and for the higher, make sure you know what vector quantities and scalar quantities. Vector quantities are quantities that have size and direction, e.g. velocity. Scalar has size like speed. If I am driving at 20 miles per hour, that's my speed. That's a scalar quantity. If I'm driving 20 miles per hour and I am going towards a school, that's velocity because I know the speed, I know the size, and I know the direction where I am going. Vectors, velocity, acceleration, force, weight, these are all vector quantities. Scalar is speed, distance, mass. Okay, distance time graphs. You are expected to know or interpret distance time graphs. So a distance time graph can look like something like this. Part A means your speed is constant. You've got constant gradient. Part B means you are stationary, you have stopped. Part C means you are on the move again. And if your distance time graph was to curve up a bit, that means it's accelerating, or you are going faster. The gradient of part A, if you wanted to do gradient, will give you speed. So distance time graph, the gradient of the line will give you speed. In terms of velocity time graph, again, if I draw something like that, part A means constant speed. Part A means acceleration. Part B means constant speed. Part D means coming back or changing direction, deceleration. Okay, the area under the velocity time graph gives you the total distance traveled, and for the higher paper you are expected to know. Right, what about velocity and acceleration? Velocity is distance traveled over time, units are meters per second. Acceleration is the change in velocity over time. V minus u over t. V is final velocity, u is initial velocity. Also, v squared minus u squared is 2 times a times x, where x is distance. Both of these two formulae I have put up are required to work out acceleration. Which formula you use depends on the information that is given in the question. If you are expected to work out acceleration and you know velocity and time, then you will use change in velocity over time. If you're expected to work out acceleration and you know distance, then you will use the second one. The second formula I would say is the more challenging formula. For the higher paper, for the foundation paper, You are also expected to know things like braking distance and stopping distances. Stopping distances, sorry, from braking distances and thinking distance. So your stopping distance is the time it takes for the car to come to a stop. It combines of thinking distance and of braking distance. Thinking distance is linked with you as a person, as the driver, the response to a hazard, which is dependent on tiredness, influence of drugs, fidgeting in the car, playing on, messing around with the radio, or using your mobile phone. All of these things are illegal. Braking distance is to do with the condition of the car and the road, tires, a slippery road, ice on the road. So just make sure you are aware of all of that. The next topic that is being tested on is the topic 3, which is on conservation of energy. So the law of conservation of energy is neither created nor destroyed. So if light bulb has 100 joules of energy, then it will give you 100 joules of energy either as light, heat, and whatsoever. Energy efficiency is the total useful energy that is given out over total energy in times 100. That's energy efficiency formula. For the higher paper, you also need to know energy can be transferred by heating in different ways. So conduction, convection, and radiation. Please note, conduction is how heat travels in solids by vibrations. Convection is the movement of heat in fluids, in liquids and gases. And radiation is the way in which energy can be transferred through a vacuum. I sometimes say radiation is the energy we get from the sun in terms of infrared radiation and so on. Okay, so just those things please be aware of, and then just do a quick overview of those. Now, next one is kinetic energy, half mv squared, and gravitational potential energy, mgh. Now, the example I normally give here to understand conservation of energy with energy transfers between gravitational potential energy and kinetic energy is think of a roller coaster. Here's a car. So you're sitting in the car is moving very slowly until it goes right to the top where you've got maximum gravitational potential energy. Here it's got kinetic energy. Goes to the top, drops. As it drops, its gravitational potential energy has changed to kinetic energy. Then as it moves up, kinetic energy changes to gravitational potential energy. When it comes to a stop, then some of that energy is transferred or carried away by heat, light, sound, and so on. And some of it is stored as thermal energy store in the wheels of the car. So that's a way of understanding this. If there's a one marker question which says state the energy transfer in, or they're asking you for a value, then you know for one marker you do not need to use your formula. You basically need to know what the energy is at the start, and that will be the energy at the end. Now, rearranging formulae is really important, and units and conversions. So I think the hardest formula you're expected to rearrange is the kinetic energy formula. So velocity equals root of 2 times kinetic energy divided by mass. Okay, so make sure you are confident in rearranging formulae. Also converting. Kilojoules is 1,000 joules. So 1 kilo is 1,000. To convert from centimeters to meters, you need to, so for example, 1 meter is 100 centimeters. So if you want to convert from centimeters to meters, you divide by 100. If you want to convert from meter to centimeters, you times by 100. That's a skill you should have done in maths. I am not expecting any questions on renewable or any major questions on renewable energy. However, just know your basics of renewable and non-renewable energy, even though the additional information is saying that they will not test you on that. Next topic is describing waves, which is expected to be coming up on the foundation paper. So this is for the foundation paper, a wave, something like that. This height of the wave is amplitude. This distance between two heights is wavelength. Wavelength is in meters. Frequency is the number of waves passing a point each second. It's measured in hertz. And the period is the length of time it takes one wave to pass a given point. There is a formula here, which is wave speed equals frequency times wavelength. So you could be asked to do a calculation here, and you could be asked about refraction. And please note, refraction is the change in speed and distance. Okay, when a wave moves from one medium to another. Core Practical 4.17 is to be assessed on the foundation paper. So you need to know how to use a ripple tank and how to use a metal rod to measure waves of solids. In all cases, remember this formula, that wave speed is frequency times wavelength, and also speed is distance over time. So I'm not going to go into the practical, but you are expected that there will be a question on that. Last topic which you are expected to know is the topic of radioactivity. Now, radioactivity topic, the bits you are expected to know about are ionizing radiations. There are three types of ionizing radiations: alpha, beta, gamma. And you need to know the properties, and you need to know nuclear equations. So just those things to cover: alpha, beta, gamma. Alpha has a charge of +2. It is most ionizing and it is least penetrating. Beta has a charge of -1. It is moderately ionizing, moderately penetrating. Gamma has no charge and it is the least ionizing and it is the most penetrating. Radioactivity is a random process, and we can measure radioactivity or activity of something using a Geiger-Müller tube. In order to measure radioactivity, you have to measure background radiation. Background radiation is the radiation that is present all the time. The main source of background radiations in the UK is radon gas, food and drink, cosmic rays, radiation coming from buildings, from things like cement, concrete, from medical equipment, and from nuclear waste. So when we measure the radioactivity of a source, we need a Geiger-Müller tube, which looks something like this, and then it's attached to a count rate meter. You will measure background radiation first in a room at 3 or 4 different places, and then take the average. Then you will take the count rate of the source whose radiation you want to measure. You will place that a fixed distance like a meter away, and you will measure its radioactivity by measuring the count rate on your Geiger-Müller tube. The count rate simply is the number of clicks per second on the count rate meter, and it's just 1, 2, 3, 4, 5, and so on. To get the accurate reading, just take that away from background radiation. Right, that's everything I would say you need to know for the higher and foundation paper for combined science. Just to mention half-life. Half-life is the time taken for a radioactive isotope to decay by a half, or count rate to go down by half. You're expected to have a graph of something like this: activity against time. And to measure the half-life of something, you just, let's say this is 100. Half of 100 is 50, so go down to 50. Go across onto the curve and come down. This distance here is your half-life. Do another half-life. Half of 50 is 25. That distance there is half-life. You are expected to know that. Right, now for triple, you need to understand the following for triple. So you will be tested on things like ultrasound, hearing, reflecting and transmitting sound, ultrasound. So ultrasound is basically the sound that humans can detect up to 20,000 hertz or 20 kilohertz. Okay, ultrasound is used in fetal scanning. Ultrasound is also used in the sonar on a ship or submarine to detect the depth of the seabed. Infrasound is sounds that have frequency of less than 20 hertz, and it is used by some animals. Also, you will need to know about seismic waves. I'm not going to go into too much depth here. Make sure you can draw your ray diagrams. What is color and lens diagrams. So something like have your lens, place your object, and I am expecting image. I'm expecting diagrams of this nature. Make sure you put your arrows on. And I think this is just a hint, just an inkling that you may get a 6 marker on history of the universe, Big Bang theory, and make sure you know what redshift is. And redshift is used as an evidence for a Big Bang theory. So it has come up so many times before. Also, make sure you read up on steady state theory, and also Big Bang theory is also backed up by cosmic microwave background radiation. So that hopefully, I hope you find that useful in terms of